Okay, so welcome to the class. Since there aren't any questions, I'm going to go ahead and do a share where we look at graphing, how to get the equation of a line, and how to use a graph. So this would be for something that you put into your lab notebook. So I'm going to change my share to my Elmo. And if I've done this correctly, you should be able to see my hands here tapping the tabletop. So let's look at graphing. So one of the first things you want to do is you want to use a large graph. So if this is your page, or this is your page, this would be okay. This would be okay. That would be not okay. Secondly, you want to label the graph. And we'll see an example of that in just a moment. You want to label the axes. And you want to write the units for the axes. And you want to put the unit in parentheses. You want to, normally if you're drawing a linear graph, you want the axes to be linear. So you're going to write tick marks. And I don't know if the tick is supposed to have a K or not. I'm going to leave it off. You write tick marks, and you want a number so that the axis is easy to read. So what that means when I say the axis is easy to read, if your tick marks are really close together and you number every one of them, the numbers get in the way, that's not easy to read. So you see this on a number of different graphs where they'll do every fifth tick mark or every fourth tick mark or something like that. Okay, now for a linear graph, you do not connect the dots unless there's only two dots. Okay, what you do is you draw a line of best fit. And it's a straight line. So let's say that we have a graph that looks like this, and I know my hand's in the way, but let's say we have a graph like this, and it doesn't matter how you draw it in your notes, but you can see that the three dots don't line up. And this is especially why I like these clear ones, these clear rulers, is that I can see the dots underneath the ruler. And you want to adjust this so that you are as close to the three dots as possible. And if you believe each dot is equally important, you want to be probably the same distance away from each dot with your line. So something like this would be the line of best fit. Now, if you only have two dots, you just connect them because that's, that's the best line for those two. Okay, now I like the slope intercept form. And some people call it the slope y-intercept form. And that's this: y is equal to mx plus b, where that is the slope, and that is the intercept. And I'm not going to go into the details there, but that's the value y would have if x was 0. And that's the same as 0b is what I should write. Okay. Let's see, what else did I want to tell you? I kind of forgot. Oh, for the slope, I don't like rise over run. And that's because if you see something like this, we can tell here that the rise over run looks like it's about 1/1. And so the slope is 1. But if this is a 5, 10, 15, and this is a 1, 2, 3, then the rise over run is really, in this case, 1/5. So the problem with the idea of rise over run is people often incorrectly use the block as a block as 1 by 1. So I use change in y over change in x. So what we're going to do here is I'm going to show you how to graph some temperatures, show you what the graph looks like, and show you the equation of the line. And we'll also be figuring out how many significant figures it has as we go along. Now, I know a little bit about this graph, so I'm going to go ahead and put the data in this upper left-hand corner, but I'm going to flip my paper around so that the dots are at the top. So for the temperature, I like to, I'm going to call this degrees Celsius, and I'm going to call this temp degrees Fahrenheit. So I normally like to write my little data list so that's like X, Y. Okay, so this is something you should know for water. And you should memorize this, that it freezes and melts at 0 degrees Celsius, which is 32 degrees Fahrenheit. I actually don't need that there because I have degrees Celsius above. And it boils and condenses at 100 degrees Celsius and at 212 degrees Fahrenheit. So if we count squares here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's about 30 squares going up here. And you can see that for my y-axis, I want to go from 0 to 212. So I'm going to do a little bit of math here and say 212 divided by 30 is about 7. And so here I could make each square 7, but that's not a very convenient number for people to work with. We're not used to counting by 7. So what I'm going to do is, rather than make each square 7, I'm going to make each square probably 10, because that way I can still get 212. So if I make each square 10, I can do this. Whoops, I can do this. 5, 5, 5, 5, 5, and this one is 50. This one is 100, 150, 200, and 250. And here you can see that to go from 0 to 212, we're going to use pretty much the bulk of the y-axis. Now, also for the y-axis here, I'm going to put temp, and I'm going to put degrees Celsius, or degrees Fahrenheit. So this is going to be 0 down here. Now, if we count squares across here, there's probably 40 or so, maybe a little more. And we have to make this work with 100. So maybe what we can do, if there's 40, each one of these is 2.5 we could do. Or we could do each one is 3, something like that. I'm not really fond of odd numbers for my blocks. I'm more like even numbers because it's easier for me to deal with. Plus, if a block is 3 long, where is 2 in that block? You have to go 2/3 of the way. It's kind of a pain. So let's see real quick if we can make each block 2 and get to 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 1, 3, 4, 5, 6, 7, 28, 29, 30. And I can see it's not going to get there. So here, I'm going to go ahead and make each block 2.5. So that's going to be 5, 10, 20, 30. And the only reason I'm doing that this time is because I happen to know that the two numbers I'm going to graph here are 0 and 100, and I know I'm going to hit both of those on a line. $10, $20, $30, $40, $50, $60, $70, $80, $90, $100. And I'm going to call this temp and degrees Celsius. So next we want to plot these 2 points. So I'm going to do 0, 32. So I know that this is 10, 20, 30. So 32 is about right there. And then 100, 212. I know that this is, this line here is 210 because every line is 10. So 100, 212 is going to be about right here. And unfortunately, I don't have a clear ruler that's long enough to draw a line. So I've got to pull out my wooden ruler. We're going old school here. This is my favorite wooden ruler because when I got out of middle school, I stole this from the teacher who used to swap me all the time. So I have a lot of a history with this ruler.
And you're really dating yourself now.
Actually, I'm lying. I know they use their bare hands. Yes, I come from an age when corporal punishment was okay. So it wasn't Sartori sit down or Sartori shut up. It was Sartori whap, sit down. Okay, but I was a pretty good student most of the time. So this is a pretty decent graph. Now, one of the things I forgot, if we go back to this, is that I didn't label the graph. So how do you label a graph? Probably the easiest thing to do is to take the axes and say one axis versus the other. So I'm going to say temp degrees Fahrenheit versus temp degrees Celsius. So that's probably the best label for your graph. If you don't know what to do, just use the axes. Okay, now normally I don't put the data on the graph itself. I'm just doing that so I don't need to get another piece of paper. Now for the slope, we're going to do the change in y over change in x. And that's where it's really nice to have this. Here's the y's. So I'm going to do 32 minus 212 on purpose. Normally we put the bigger number first, 212, but I'm doing it backwards. Now for the change in x, whatever my y is here, I use the x here. So 0 minus 100. And we get negative 180 over 100, which is, and I'm sorry, negative 180 over negative 100, which is 1.8, or some people leave it as 9/5. Now I want to talk about significant figures for this value here. These numbers over here are all defined. So what does that tell you about how many zig figs they have? The answer is they have an infinite number of zig figs. So if you have infinity minus infinity, how many zig figs do you get? Infinity. Same down here. If you have infinity divided by infinity, how many zig figs do you get? Infinity. So this has infinity zig figs, and here the 9 and the 5 have infinity and infinity. All right, the best way to get the B value is to just plug in a y and an x. And for these two values here, this 0.32 makes the most sense. So we know that m is 9/5 now, x is 0, b is equal to 32. So you can see that in this case, b is equal to 32. So our equation actually ends up being y is equal to 9/5 x plus 32. And how many significant figures are in this 32? Well, that 32 is defined, so this is infinite. And really, at this stage of the game in Chem 1A, this is not good enough. What is good enough? Well, usually what you do here is you look at that and you go, oh, y is degrees Fahrenheit. X is degrees Celsius. And there, you have a formula for going between degrees Celsius and degrees Fahrenheit. Now, on an exam, you should not graph this formula. You should memorize it. Or, you know about the 3-inch by 5-inch card, you could write it down. For the quiz, you should memorize it.
Tony, Tony, you wrote 22b equals b over there instead of 32.
Thank you.
You're welcome.
I didn't notice that. So there's how you graph. That's how you get the equation of the line. This would be how you show your work if I asked you to show me your work. And that's all there is to it. Now, I'm going to flip this over. Actually, I'm not going to flip it over. I'm going to draw another graph here. So I need another piece of graph paper. So this would be a pretty good sized graph. You can see I've used most of the paper. So remember how I said your graph should be at least half of the page? This is half the page. And let's say that this is 10, 20. I'm going every 5, 30, 40. And over here, this is 5, 10, 15, 20. And we're going to call this mass in grams. And we're going to call this volume in milliliters. All right, now let's say I get the following points on my graph. Okay, and I draw my line of best fit. Now this line may be short enough where I can actually use my plastic ruler. And can you see how that looks like a pretty good line between those 3 points? I'm going to make these points a little larger so you can see them through my plastic ruler a little easier. Can you see how that line would be pretty good? Now let's say we have evidence to state that when you measure the volume here, you know that volume is too small and it should be larger. Well, then you can actually tilt this, because if the volume actually tilted this way, because if the volume were larger, it'd be more this way, and you could tilt it more like that. So that's what's really neat about the line of best fit, is based on evidence you have for whether or not these dots are good, you can have them influence the line more or less. And computers can't do that. So I'm going to assume each dot is equally valid, and I'm going to draw something like this, and I'm going to try and continue that. So there's my line. Now, how do we get the slope of a line like this? Can I use this point here, which looks like it's about 6.5 and 4. I'm going to call that 6.5 and 4. This one looks like it's about 22. So we're going to call this guy 22.2 slash and 13.2. And we'll call this last one 39.0 and 18. So which 2 points would you use to get the slope of the line? And the answer is none of them. And the reason for that is because none of them are on the line. So what points would I use to get the slope of this line? And the answer is I would try to find points like this one right here. Do you see where that point is on a crosshair? So it's easy for me to see what that point is. This point is 16, and it is 9. And I can read that very easily. Here's another point where it looks like it's right on the line. So I'm going to call that 32, 34. And over here, 17.0. So a lesson I'm trying to teach you here is if you have multiple dots on your line, for your line, and the line doesn't go through any of the dots, you can't use them to get the slope. So I'm going to put these in squares or rectangles and say, you know, these are what I'm going to use to get my slope. And so the slope is change in y. So I'm going to do 17 minus 9 over 34 minus 16. 17 minus 9 is 8.0. 34 minus 16 is 18.0. And here you can see that I'm going to get around 0.5, but a little bit less. And I'm glad I did that little estimate because when I just plugged this into my calculator, I got 0.0033. I knew that was wrong, but I just got 0.444444, and I'm going to keep 2 zig figs because of that. Now, what is B? I'm going to go ahead and use the 9 and the 16 here. So if I take my 0.44, multiply by 16, and subtract that from 9, I'm going to get that the difference is 1.9. And if we take a look over here, does it look like the line crosses around 1.9? I would argue that it's really darn close. So what would we write for our formula? Well, initially we might write y is equal to 0.44x plus 1.9, but y is really the volume. And x, excuse me, y is really the mass. I got to erase that. And x is the volume. So here we've got a formula where if we're given the volume of something, we can calculate its mass, or if we're given the mass of something, we can calculate its volume. Are there any questions about what I've done there, or why we don't use any of the points used to make the line, but we do use points on the line? Any questions? So that's a yes or no. Give me a no if you're okay with that.
Sorry, writing.
Really? Okay, we got 2 no's. So we're ready to move on. And so I just want to talk to you a little bit about graphing and also introduce that temperature conversion that you should memorize, because you'll probably need that on the quiz or the exam. And remember, you're supposed to be taking that quiz by the end of tomorrow. Today was the original deadline. I extended it to tomorrow. If you want to work on the weekend, that's fine with me. And you can take it multiple times. And we keep the best score. So you don't want to lose on cheap points. You do have to take the quiz in Chrome.
Tony, I have a question about that.
Sure.
I was reading it and it said that we have 30 minutes for the quiz. So does that mean that we only have 30 minutes, like unlimited tries within those 30 minutes, or can we access it after that too?
It should be 30 minutes for each try.
Oh, okay. Okay.
And the reason for the limit, even though you have unlimited tries, the reason for the limit is to get you used to getting things done correctly and quickly, because on the exam, you only get one try.
Right.
So it's kind of like a practice for taking the exam, except for the exam is not multiple choice. And that's the downfall. The nice thing about this quiz being multiple choice is you get immediate feedback. And I've chosen that you will be told if your answer is wrong.
Okay.
But I've also chosen that you won't be told what the right answer is.
Yeah, I saw that.
So that puts a little bit more on you to actually try to do the work and get the right answer and understand it better. So that's why I chose those things, so that you could get feedback, but not just be fed the answer. And
Right.
I think most students like that.
Yeah.
Okay.
Tony, Tony, is that the same format that the other quizzes will be in, or are they going to be?
The answer is yes.
Okay.
The quizzes are low stakes. It's only 10% of your grade. And I think it's great if you can guarantee that out of 100%, you can lock in 10%.
And I love that it's actually set up to train you rather than to make you nervous. So thank you.
Well, some people are still going to get nervous, and
well, nerves happen, but training you how to deal with the nerves and still function is part of learning. So again, thank you.
One of the things I can tell you about nerves, though, is that if you take the edge off before an exam, you'll probably do better. And one of the best ways to take the edge off is go for a 10-minute quick walk before the exam.
Smart.
It opens up your mind, it relaxes your body. And when I say a 10-minute walk, really 20 minutes before the exam, take a 10-minute walk, rest for 10 minutes, and you'll feel alive.
Great, thank you.
And whatever you do, don't drink booze before the exam, because that's what relaxes you.
What, that doesn't take the edge off?
It does, but it also takes the edge off of your mind.
Uh-huh.
So that's not a good idea.
Got it.
And this is a true story. My mentor at the college told me that a student in his class was not doing well. In class, answering questions, they did really well. On exams, they just blew it. And then on the third exam, all of a sudden, they did really well. And another student said, "Oh yeah, that's because I saw him in the parking lot taking a shot before the exam."
Professional alcoholic.
Yeah, so you really don't want to do that, though, because it takes the edge off of your mind. Okay. So let's go ahead and take a look at some problems from the book. I believe we had looked at 22 already. I believe we've looked at 24 also.
Yep.
And 26 we did.
Yep.
And 28 and 30 we didn't do because they're simply too long. But I think I looked at the problems in the book and I decided that maybe they weren't too long. So let's take a look at 28 and 30 real quick. Okay, so we're going to look at 28, and 30 is actually a problem on your homework. So we're not going to take a look at that one. But let's look at 28. So I'm going to zoom in on this a little bit. And without going into any detail, I'm just going to ask you to try to answer these questions. When you're done, give me a little signal that you're done, like a check mark or a, yes or a no. I don't care, a no, some sort of signal, and I'll tell you what my answers are, and we can talk about that. I am going to ask you a question before you get into too much detail here. This is a yes or no. How many of you would like me to play the Jeopardy theme music to help you do this problem?
Yes.
We got one no. One of us wants the Jeopardy theme music. You're kidding me. You really want the Jeopardy theme music? It's a 2-2, so we're not going to do it. For those of you who wanted it, just hum it to yourself and you should be fine. Normally I would pause the recording here, but I've been having old folks problems of forgetting to remember to restart it. So I'm not going to bother pausing it. And we're looking at number 28. So remember, you're going to let me know when you're done. You're not claiming that you got it right, because I'm not going to put you on the spot and ask you what you got. Okay, we've got a couple of people done. I'm going to go ahead and start. And the first thing I'm going to start with is this right here. You can see that the closest lines on the bottom are 0.1 apart. This is 0.1, this is 0.2. So that's 0.1 apart. If we do a 0.2 minus a 0.1, you can see that they're 0.1 apart. So that means we should be able to read to a tenth of that. So I could read 0.11, 0.12, 0.13, 0.14. And that last number would not be exact, but it would be precise. And for this value here, I know it says 4.00 and 5.00, but really the difference between 5 and 4 is 1. So the tick marks, as it were, there are 1 apart. So I should be able to read to the 10th. All right, so they say when y is 4.0, so I'm going to go here to 4.0. It goes over to the graph, and then I'm going to go down from there. And you can see that when I line up my ruler, I get pretty close to where I wrote that little tick mark. So for A, I'm going to write the value of 0.2, and then I'm going to guess that it's 2/10 of 0.2 on the way to 0.3. So 0.22 is what I would write. And if you had something like 0.25, there's no way. No way. But if you wrote 0.21, fine. 0.23, fine. Okay, what is the value of y when x is 0.30? So here we go. For 0.30, I'm going to do this. And you can see that it seems to go halfway between 5 and 6. And so when it looks like it's really halfway, your inclination is to put 5.50. And that's wrong. You can't really read that on the side here because the difference between those values is 1. But we could write 5.5 to a 10th of the 2 closest lines. C, what are the slope and y-intercept of the line? So all of these points are on the line. So we can actually do this with the points we have. So the first value I'm going to use is 0.22 and 4.0. And then I'm going to use 0.30 and 5.5. Since we already put the effort into getting these values, I'm going to use those for the slope. So the slope is going to be 5.5 minus 4.0 over 0.30 minus 0.22. So I get a difference here of 1.5, a difference here of 0.08. So it looks like I'm only going to get one significant figure for my slope. Not really fond of that, but you know, those are the breaks. And the way I think about the answer here is I think that if this were 0.8, the answer would be about 2. But since this is 10 times smaller and in the denominator, the answer should be about 10 times bigger. So the answer should be around 20. And I get 18.75, which becomes 2. Oh, I'm sorry, 20. And for the b-intercept, I'm just going to read it right off the graph. And looking at the graph, it looks like it's 1/10 of the way. So I'm going to call b is equal to 0.1. So that means that the equation of the line would be y is equal to 20x plus 0.1. Are there any questions about that? That's a yes or no. Any questions? Okay, we're going to go ahead and move on then. So that one was worthwhile because it tied in with what we had just done. So 30 again is a homework problem. I'm going to zoom back out so you can see, again, I zoomed in on the other one just so you can see the problem a little better. Now, I think we actually did this problem and solved it for n. And I'm pretty sure we also solved this one. And this is one where even if we have not done it We've done these types of conversions before. Don't bother with the angstrom one. I know that this has been recorded in other videos.
That was within that last video, the
Yeah.
evening yesterday.
And this one I've also recorded in other videos, but have we talked about this particular problem in this particular morning section?
No.
Then let's talk about this one, because I expect you to do this problem in a particular way.
Yep.
And I'm going to justify it. And after I justify it, even if you don't agree with it, that's too bad. You're going to do it my way. Okay, so we have a drug called cisplatin, and it contains 65 mass percent of the metal, and it's basically platinum surrounded by four molecules, I believe. So it looks something like this, if I remember right. And this is cisplatin, but they want to know, what is the mass of platinum if you have 1.53 grams of this? So the first thing I'm going to do is I'm going to do it the wrong way. 1.53 grams times 0.65 is equal to 0.99 grams. So this is not very good, and I'll tell you why. We just changed 1.53 grams into 0.99 grams, but we have no justification for what this is grams of and what this is grams of. We also have no justification for turning 65.0 into 0.65. We just did it. And I know your math teacher said, move the decimal over 2 places and you're good to go. But what's the reason? Why move it 2 places? Why move it 2 places to the left instead of 2 places to the right? I mean, if we take a look at this and we turn that into a fraction instead of a percentage, half the students I present this to, under stress naturally, will write 0.52. They can't fathom that it would be 0.000052. There's no way. And this is wrong. Because our natural inclination is to not make a number so that we have a bunch of zeros in front of it. We'd rather do that, even though this is wrong. So I'm going to give you the definition of percentage. And it's going to be the definition of X percent. That's equal to X over 100. And this 100 has infinity significant figures because it's defined. Okay. Furthermore, it's the X represents the part and the 100 represents the whole. So this means that over here, for the 65.0% for the cisplatin, that means that there's 65.0 parts platinum over 100 parts cisplatin. Now, in this case, since they say mass percent, guess what the part is? It's a mass part. I'm just going to write cis because I don't want to write the whole word out anymore. I'm tired of it. So we can put any mass here we want. I could put pounds here. I could put stones, because you're from England and you like the idea of stones being a weight, a measurement weight number or unit, I should say. But when we read the problem, what mass unit do you think we want to put here? I'm thinking grams, don't you think? So there you go. Another thing by doing this is you'll notice we kept the 65.0 with 3 significant figures. And here, when we move the decimal over, we forgot to put the 0 on the end. All right, so now this means that 65.0 grams of platinum can be found in 100 grams of cisplatin. So if I start with 1.53 grams of cisplatin, I'm going to multiply by the 65.0 grams of platinum on the top and the 100 grams of cisplatin on the bottom. And here, notice that the grams of cisplatin cancel. And we're going to get grams of platinum. And we can see that we're going to end up getting about 2/3 of 1.55. And my calculator, I believe, gives me 0.9945, if I remember correctly, but I'm going to do it again. I get 0.9945. So I want to keep the 0.9 and the next 9. I want to keep the 4, but I look to the right and I see it's a 5. So when I see a 4 here and to the right is a 5, what do I do with that 4? Round up. So 3 significant figures, because this has 3 zig figs, this has 3 zig figs, and this has infinity zig figs. So this is the work I would expect to see on an exam. And if you did this, I'd give you some credit, but not like passing credit. And even if you did this, I'd give you some credit, but not passing credit. So what I have rectangled off here, I'm going to put an X through and say, don't do that. So this is a much better way to deal with percentage. Instead of moving a decimal over 2 places and trying to remember which way to move it, don't move the decimal over 2 places. Instead, divide it by 100. We divide it by 100 because the definition of percentage is divided by 100. Are there any questions about this? None? Okay, so take a look at this problem. Don't look at your notes. Try it. Don't look at your notes. Give me a little thumbs up when you're done. So hard to sit here because it's sunny out. How are we doing? Okay. I know one of you gave me the thumbs up. We got another thumbs up. So the reason I had you do this just now is because I explain it, I show you what I want. And even if you don't like what I want, you kind of understand, okay, I think I know how to do it. And the reason I asked you to cover your notes and try it again is because, well, if you really, really, really understood it, you'd just be able to come up with a solution, but understand how you came up with it. Too many times, And I shouldn't say too many times, a number of times we find out that, oh, there's something I'm kind of missing here. And then you go look at your notes, and that's okay because you're figuring out where the block is and you're using your notes to get through the block. And the next time you try it, you'll probably be okay. So, you know, a lot of times when someone shows you how to do this, it looks simple and you go, fine, I can handle it. But it's really in the doing that you learn it, doing it by yourself. I remember when I was in Boy Scouts, I took a canoe class, and they went out and demonstrated some maneuvers on the canoe, and they came back to shore, and they just picked a random pair of students to give it a shot. And since I never imagined in my life that I would be one of the first two students to be asked to do it, I just didn't even pay attention. So I went out on the canoe and tried to remember what the heck they did, and I didn't really remember very well. And my partner, when we got back to shore, he was crying because I screwed up. And I think that's the thing that bothered me the most is I made another Boy Scout cry. So I quit the Boy Scouts.
Aw.
Yeah. So I'm not a Boy Scout anymore. I know it's a stupid story, but imagine if I had paid attention. First of all, I probably would have done better, but there's no guarantee that once I got out there, even paying attention, that I would have done it right. There probably would have been a mistake or two that we made. We would have come to the shore and the scout leaders wouldn't have said, next time, pay attention, you dummy. Instead, they would have said, well, remember that one maneuver where you traded places? You probably want a lower center of gravity because you got kind of tipsy. You know, they probably would have given me more feedback. Low center of gravity is crucial when you're moving around in a canoe. Okay. All right. Let's move on. Sometimes a problem will be given to you and you can't solve the problem with just one stroke or one solution. You might need to do a couple of things. And this is an example of that. So take a moment and read this one and I'll show you my solution. Okay, so I'm going to write mass is equal to 7.6 grams. I'm going to put 2.698 grams is equal to 1 centimeter cubed. I know this is written as a ratio, but I write it as an equality. And I know that I want the length of an edge. So the connection between these is that the length times the length times the length is going to equal the volume. That's the deal for volume of a cube. So I'm thinking I'm going to take my mass, I'm going to turn that into a volume, and then to get the length of the cube, I'm going to actually have to take that volume and take the cubed root of that volume. So really, it seems like I have two things to do here. I don't know how to incorporate a cubed root into that automatically. So I'm going to take my 7.6 grams, and remember the last problem where we used platinum and we used cisplatin? Here we don't need to do that because everything here deals with aluminum. But I'm going to go ahead and put aluminum anyways. And when I put aluminum here, it actually explains this a lot more. What I mean by that is, how does a gram equal a centimeter cubed? Well, when I say that many grams of aluminum is that many centimeters cubed of aluminum, it kind of makes more sense. I'm adding information here. So when I write this out as an equality, I am perfectly fine with taking this 2.698 grams of aluminum and putting it on the bottom, and the 1 centimeter cubed of aluminum on top. Whereas if I had left this as 2.698 grams per centimeter cubed, I would have looked at that and said, is it okay to use that upside down? And the answer is, yeah, it is. But I'm more likely to do that here if I write it out as an equality. Okay, so that's the first problem. And we can see that we're going to get 7.6 divided by 2.698, which should be around 3. And I get 2.81, I'm going to put 7 centimeters cubed of aluminum. And I'm going to put a little arrow here to my 8 because this has 2 significant figures, so this should only have 2 significant figures. But I'm not done with the problem, so I'm going to keep the extra significant figures for right now. So the length is going to be the volume raised to the 1/3 power. So that's going to be 2.817 centimeters cubed to the 1/3 power. So to do that, I'm going to take my answer here and raise it to the 1/3 power. So let me see if I can do this. 1/3 and 1/3 I'm going to put in parentheses, 1 divided by 3. And I get 1.4 centimeters. And now, since I know this has 2 significant figures, and whenever you raise something to a power, you use the multiplication rule. So this ends up having just 2 significant figures, even though my calculator writes 1.412289, etc. So this is the kind of work I would expect to see here. If you have the arrows in there to help you keep track, fine. If you don't have the arrows in there to help you keep track, that's fine too. When I'm writing out a solution, I use little tricks like that to help me keep track because, you know, it's the old age thing. If I don't do it, I'm going to forget. Fair enough. Any questions on that one? Are we good to move forward? Yes or no?
Mm.
Okay, then we will move forward. 42 says refer to the book. So let's take a look at 42 and see if that's one that we should spend some time on. Page 53. I really like this right here because I have a hard copy, so I can flip to the page very quickly. 42 is a great one for us to look at because I can just let you have at it and give it a shot. Let me zoom in on this for you. I'm not going to bother writing it down, but I'm going to let you read the problem and ask you to try to solve it. I'm going to hit the autofocus here, so it's going to look like you're at the eye doctor where the thing goes in focus, out of focus, in focus, out. It's not you, it's me. Okay. When you're finished, just give me a thumbs up. Okay, we've got one, and when another view is finished, I'll go ahead and show you what I would expect to see on an exam for something like this. Okay, we've got 2. So I'm going to go ahead and show you what I would expect to see. And since we're using density to decide what the substance is, I'm going to write density is mass divided by volume. And then just to save space, I would write 18.82 grams. Let's see if I can fix this. And for the volume, I would use this 15.3 minus 8.5. And I just go ahead and put it right in here like that. And you'll notice here, I put the milliliters on the outside of the parentheses. That way I didn't have to put milliliters here and milliliters here, but I could have. That would be fine. Now, this part I wouldn't write on the exam, but I'm going to write it over here to the side, 18.82. And if we do 15.3 minus 8.5, we get 6.8. Now, we're doing subtraction here. We use precision to round. Since this value is good to the 10th and this is good to the 10th, this is good to the 10th. So now we're doing division. We have 3 or 4 zig figs and 2 zig figs. We're going to round to 2 zig figs. So I'm going to divide 6.8 into 18.82. And I get 2.767647, but only 2 significant figures. So 2.8, the grams doesn't cancel, and neither does the milliliters. So this is the work I would show. And then lastly, I look at all of these. And if I wasn't asked to justify numerically, I'd say it's KBR. And that's because its density is closest to 2.8. So that's my justification. Just getting the number here isn't good enough. You actually have to identify it. Are there any questions there? Destiny, you have your hand raised. I'm sorry, I didn't see that.
I think you just explained it, but you said when you said 2.8 and then you said if I don't have to justify numerically, then you chose C. But what do you mean by you don't have to justify numerically? Okay,
and that's a great question. So how would we justify our answer numerically? So what we're looking for is how would we justify the accuracy of 2.75 of 2.8 being KBR? How do we numerically evaluate accuracy? And the answer is you do a percent error. So we could do, since this is the accepted value, we could do 2.8 minus 2.75 over 2.75 times 100%. And then we could do, if it were KCL, you would do 2.8 minus 1.98 over 1.98 times 100%. And you would find out which one had the smallest percent error, because that one would be more accurate, and that would be numerically justifying which is the correct answer. So good question. I'm glad you asked it. Did I take care of that concern? Excellent. Okay, well, let's move on. So we just did 42, and I need to zoom out because I see you're looking at what's written on the sheet behind because it's coming through the paper. So let's take a look at this one. Diamond has a density of 3. Well, you can read it. Let me just give you a chance to read it. Okay. So how I might start this one is with the density here, where I put 3.513 grams of a diamond. So I'm going to put a D here for diamond, is equal to 1 centimeter cubed of diamond. And next it says where 1 carat equals 0.200 grams. So I'm going to put 1 carat, because I don't know an abbreviation for carat. 1 carat of diamond is 0.200 grams of diamond. So that's another conversion. What is the volume of a 1.50 carat diamond? So I can see that I'm going to start with 5.0 carats of diamond, and I'm going to convert from carats of diamond to grams of diamond, and then I'm going to convert from grams of diamond to centimeter cubed of diamond. And you'll notice in a lot of these problems, I'm writing out a little roadmap of how I'm going to convert things. And I've already told you I'm not going to ask for that on the exam, but it's so helpful. And this took me less than a minute to do. So now I know that I'm going to start off with 1.50 carats of diamond, and I'm going to use the conversion that has grams of diamond and carats of diamond. Here it is. And I'm clearly going to put 1 carat of diamond in the bottom and 0.200 grams of diamond on the top, so that these cancel. And then following my roadmap, if I'm going to go from grams of diamond to centimeters cubed, I'm going to use this guy up here. And I'm clearly going to put 3.513 grams of diamond on the bottom and 1 centimeter cubed of diamond on the top, so that these cancel. And so clearly, based on what I've written here, the answer is centimeters cubed of diamond. And the beautiful thing about writing it all out like this is I can look at the significant figures very easily. I have 3 here. I have 3 here. The one is infinite. This one is infinite. And I have 4 here. So I'm going to be left with 3 significant figures. And we can even estimate the answer. 1.5 will go into 3.5 about 2 times. So that becomes 1 over 2. 1 over 2 times 0.2 is the same as half of 0.2. So the answer should be around 0.1. It's going to be a little bit less because 1.5 doesn't go into that 2 times. It goes in a little bit more. But we're going to expect an answer around 0.1, maybe 0.09 something, and so forth and so on. Why do you think I estimate all the time?
To check yourself.
Because I have messed up so many times by not estimating, looking at my calculating and saying, oh yeah, that makes sense. So here, I just wrote this problem out and I get 0.000085397. And I said the answer should be around 0.1. I messed up. And when I look back, I see, oh, I didn't put the decimal in the 3.513. So I'm going to go back and fix that. I mean, this is a real-time mistake here that I did. And make sure I get that decimal in. And now my calculator says 0.8539. And I said the answer should be around 0.1. So another real-time mistake. I didn't put 0.2. Jeez Louise. My son was making fun of me last night because I was typing something out, and he said literally every word I misspelled and had to go back and fix it. And of course I said, no way, I did it okay. So I'm going to round to 3 significant figures. I'm going to keep the 8, the 5, and I don't have a 4 there. I have a 3, but next to the 3 is a 9. So I'm going to round that up to 4. And this is a beautiful demonstration of doing that conversion. being able to count zig figs, and it's like beautiful. The only thing that can make this better is if I wrote this, D equals diamond. But I don't think that's necessary. Are there any questions here? Actually, let me ask you this. Go ahead.
I realize it's my brain right now, but the sig figs, I've lost where.
This has 3.
All right, trailing after decimal. I just found my own.
Yes,
Yeah.
trailing decimals count. I'm sorry, trailing zeros count if you can see the decimal.
Yeah, thank you.
Okay. All right, let's go ahead and move on. Actually, it's 11:16, so it's time to quit.
Okay.
All right, so the rest of the problems here are very similar to ones we've already done, just more of the same. What's going to happen on Monday is we're going to actually start problems from the end of chapter 2, because the lectures for chapter 2 are already posted. And you should start watching those this weekend, and prepare yourself for doing some problem solving on chapter 2, end of chapter problems. I'm not sure what the next lab is going to be, but I wasn't really happy with any of them last semester. So I have to spend a little time this weekend rewriting them to give you a little more structure. But it probably will be mass spectrometry. It'll be either that or Avogadro's number, which we didn't do last semester for a number of reasons, but we might do that one on Tuesday, and mass spectrometry on Thursday. Hopefully you have your kit, because you'll need your kit for the Avogadro's number lab. For mass spectrometry, you're going to have to go online and find a mass spectrometer, purchase it, and have it sent to your house. They're only about $100,000. So when you get that, let me know. And of course, I'm kidding. You're not going to buy a mass spectrometer. Is that clear?
Yes.
Okay. Not even an old broken up one. Destiny, go ahead.
I was wondering, for this science lab, lab 3, are we writing that in our lab notebook because it's like an essay format?
You know, that's a great question. And you'll note, I don't know if you noticed, but the submission actually says that you're going to write it in, you're going to type it in, and there's no file upload.
Oh, okay.
So with that, I was thinking you would not put it in your lab notebook.
Okay, I didn't look at the submission. But...
So what I'm going to do is I'm going to go back to that description of the lab, and I'm going to say, you do not need to write this in your lab notebook. Does that sound good?
Yeah.
That'll clarify it for everybody, and I'm glad you asked that question.
And then
Okay.
Also for the density lab, are we writing our hypothesis in our introduction, or do we just start our discussion with what our hypothesis was?
Oh, in that case, I would write the hypothesis in the introduction.
Okay.
You know, I would write down density is blah. You determine mass with a scale, and you determine volume by displacement or by geometric shape. Pennies and dimes are made out of metals, and it looks like pennies are made out of copper and dimes are made out of zinc. So in this lab, we're going to get the density of pennies, the density of dimes, and see if the density of pennies does match that of copper, and if the density of dimes does match that of zinc. That's what I would write in my intro. That's
Okay.
simple. Does that help at all?
Yeah, thank you.
You bet. Okay. Anything else before we go? Okay, so now's the time to turn on your mics and say goodbye to everybody.
Bye.
Bye.
Goodbye. I hope to see
Bye.
you today.